Hi. If I drop a textbook and an eraser at the same time, what do you think is gonna fall first?
I think the eraser will fall first.
Eraser.
Textbook.
Why?
Because the textbook's heavier.
So it's lighter.
Well, they're both gonna land at the same time.
What?
How?
How? I would want proof.
Like this?
How am I gonna prove it to you?
In a 3-minute video. All right, welcome to the Force of Physics. Let's see what we can learn. Found the first treasure box! Great, that treasure box gave us just what we needed. Newton's first law. It states that an object in motion stays in motion at the same velocity or the same rate. But Newton's first law also states that an object which is stationary wishes to remain that way, or in a state called inertia, until of course an outside exerting force affects it. So now let's take an example of an object staying in motion at the same velocity by visiting an air hockey table. Here, the speeds of our objects stay roughly constant as the sides of the table have effect. Picture it this way. You're rolling a snowball and you notice it's getting harder to push. That's because as it gets heavier, it collects more inertia too, while your force gets weaker. But leaves don't move at a constant speed. Found the next one. Newton's second law of motion, connecting everything that we learned in the first. It connects the three factors that we briefly touched on before: mass,
or the weight of an object,
acceleration,
or the change in speed,
and F-net. F-net is the amount of force acting on an object,
made up of other forces like friction and gravity.
But let's touch on F-net just a little bit more. It's like mixing colors to create a new one. All active forces pitch in. The second law of motion puts these three factors into a proportional formula of F-net equals ma. Take a look here. Two cars are pulled apart in part A, but one has rocks attached to it in part B. The change in weight affects the acceleration and F-net of the white car. It goes slower. But why does the dropped paper move side to side? What's up with the F-net? Oh, there's another one! Perfect. Newton's third law of motion, wrapping up everything that we learned today. It states that every action force has an equal but opposite reaction force. Similar to how I'm sitting on this tree branch. My force is acting down upon it, but the tree branch has enough strength to push me back up, which is why there's balance and I'm not falling. But for another example, follow me. A weight machine can give you a better picture. It has a set weight to resist your force, which also builds muscle, showing how the opposing forces work. We can synthesize as to why the textbook and the eraser landed at the same time. The textbook's mass was 54 grams and the eraser was 5.1. The book's F-net was negative 5.3 newtons and the eraser was negative 0.5, both values being 10.6 times different. Applying the second law, the accelerations come out to be 9.8 roughly meters per second squared, the force of gravity. And the reaction force from law 3 was the normal force coming up from Earth, creating balance as the equal speed stopped. Give yourself a pat on the back if you learned that today. This is Nikita signing off.